Okay, I'm going to build a very simple wood screw like this. You can see it's quite realistic. Um, this is a helix structure here. You can see highlighted in yellow. And the shank here has got a fillet, which is very realistic. And there's a fillet here. This was just one piece, but put a fillet on there to make it two. There is a problem with this design. You can see that down here, some of it just hasn't worked out well, and if anyone's any ideas how to resolve this here, please let me know. I have no idea what causes that. You can see that I've swept along the helix using this small white sketch here. You can just see it there, and this upper white sketch over here. So I essentially sweep these two shapes, or sweep from one to the other along the helix, and I essentially sweep between them, and that gives me the thread. So what I'll do now is I'll show you the inside there. That's quite realistic as well. It's got a nice chamfer on the edge there. It's altogether a realistic screw. It's a realistic size as well for joining something to a 90mm pine bead, and it's modelled from a screw I have in front of me. From top to bottom is 17mm, and from here, from the shaded yellow line there down to the point is 15mm, and that of course leaves 2 for the top there. So I'll now show how I built this. So let's start a new drawing. We're already in part design, which is where we need to be. We'll create a body, create a sketch. We'll sketch on the X, Z plane. Okay. And we're going to create that little triangle at the bottom as the first sketch. So 1, 2, 1, 2, 1, 2. There we are. And then this one here is constrained to, let me see the size I used, 0.1, and the top one here was constrained to 0.05. So there we have a fully constrained first sketch. Let me just bring this along. So if you want to follow along, you can see the sizes in use. There we are. Those are the sizes in use. So this, the dot selected there at the tip of the mouse cursor is the tip of the screw. And this here is going to sweep up in a helix fashion like this, up to the next sketch, which I'm just about to make. So second sketch is again on the XZ plane, and it's, where's our first sketch? There it is. So it's about, I'll zoom into that because it's about the same order of magnitude and size. Make this a little easier. I'll choose the polyline to make this. It just goes a bit quicker. Okay, so first things first, that line and that line are equal, so I press E. This line here is, is 0.6 mils. That point there to that point, the horizontal distance is 0.8. let me check I've got this right. 0.6, yes, 0.8. This distance here to here is 0.3. And that distance vertically from between those 2 points is 3 mil. Okay, so let me just, you can see we're going to sweep from this first sketch at the bottom in a helix all the way up to here. So let me just make this nice and clear so you can see all the sizes. There we are. I'll just do a quick check again. 0.6, 0.8, 3, 0.3. Yes, those are all the sizes I used, and it's fully constrained, so we'll close that. So we've got our first 2 sketches. Now I'm going to just see where that is. Oops. There we are. So, yeah. Okay, sorry. So now I'm going to make the cone at the bottom, and then put the cylinder on top of that, and then the head on top of that. So this is very simple. So we go to Part. I'll do the helix in a moment. I just want to get this going so you can see what it looks like. Select that. The cone has a point radius of 0. The radius of the shank is 0.75, and the height is 3. There we are. So you can see we're sweeping up the tip of the screw from the white there to the white there. So now I'm going to create the shank, or the main body or cylinder for the thread which sits above the cone here. So I go up here, I click on cylinder, create a cylinder, make sure to select the cylinder, come down here into combo box, the radius is 0.75, the height is 12 millimeters, and then I come up here to placement and I click on the 3 dots there, and the offset is going to be 3 millimeters. And there we are. There is the shank or main body for the screw. Okay, and let's do our screw head at the top. So it's another cone. 0.75, 3.25. The height is 2, and the Z offset is 15. There we are. That bit went simply. Okay, straightforward. So now I'm going to put the helix on, and how I do that is we're already in Part where we need to be. This menu here, creation of parameterized geometric primitives. So we go in here, we choose helix. The pitch for this one is 1.3. The height is 15. The radius is 0.75. Create. There we are. There's our helix. All the way up to the top. Close that. And now what I'm going to do is turn the view of the cylinder and the cone off, and I'm going to sweep from there along the helix, this helix up to here. So to do that, what I'm going to do is, oops. To do that, what I'm going to do is choose sweep. Sweep, okay. We put in the first sketch and the second one because we're sweeping from one to the other. Create solid, frenette, sweep path, and then we choose those first 2 there. Done and okay. And there it's swept. And then the second one, we choose sweep again, utility to sweep, choose a second sketch only, because we're sweeping from that all the way to the top. Create solid, friend it, sweep path. And here's the tricky bit. If anyone knows, so I have to select all of these after the first two. And if anyone knows, if you've got a long, see, that is infuriating, because the easiest way I found to do this is to make it fairly small and just go all the way up to them like that. And I left the last one because doing that one made it sweep into the screw head, which we don't want. So if you know of a way to select all these helix parts without having to click each individual one, please let me know. So click done, OK, and that's that swept out. And now, that's in essence the screw created. We can hide the helix now, show the cone, where's the cone? Yeah, show the cone, show the cylinder. So you can see we've in essence got our screw there. So what I'm going to do next is I'll merge these two parts, the cone and the cylinder, with a fusion there. Make union of several shapes. That's them unified. I'm going to put a 2mm chamfer on that. 2. And that just makes that a little rounder, as you can see. And what we can, so you can see this screw at the moment looks really nice. It really does. But watch what happens when we take this union of parts. So let me just put that back to normal view. Okay. So when we now take the fillet, which is joined, the cylinder and the cone joined, and the sweep. Well, let's union the sweeps first. Put those together in a fusion. Make union of several shapes. Okay, that seems to have gone okay, and it's still fine at the tip. You remember at the very start of this short video, the tip was there was a problem down here with creating the solid. So what we'll do now that we've joined the thread into one thread, it was two before, remember, we'll take the fillet and the fusion and we'll union those. This is where the problems start at the tip. So if you look at this now, look what's happened. We've got this very curious problem here, which is rather horrible, actually. If anyone knows how to fix that, you can see that the cone is trying to come down, but a bit of the cone is snapped off and a bit of the cone's missing there. If you know how to fix that, please let me know. So now I'm going to go up to top and I'm going to see if I can draw on that plane. I don't know if I can. I have to go to part design, I think, to do that. Where's the plane there? Oh yeah, perfect. We're on the plane we want to be on. Okay, make dependent copies. What I found worked. Create a sketch. Make dependent copy. Fine. And now I'm going to select create a polyline. Oops. It's easier if you just get them all nice and straight at the beginning. So this is our screwdriver slot. Oops. Oh gosh. Okay. So to merge, to merge these 2 points, okay, so I want that to be parallel, Oops, it already is, and that one as well. And then I'll come back to merging the 2 points in a moment. It obviously needs to be done. So oh gosh, I've lost my sketch again. Okay, we're back. So all we need to do is select those 2 points and press, oh, yes, no, it's not C. It's, it is C. Yes, okay, coincident. There's some join. So now I want to make these all equal in length. Oh gosh, I dropped them. E for equal, there we are. And I want to make all of these equal in length. Equal, right. And I want to make this line symmetric around the x-axis, S for symmetric, and this line here symmetric around the y-axis, symmetric. So 2 degrees of freedom. This dimension from here to here is 4 mil, 4, and just 1 degree of freedom, and we can close that off by putting this here, that dimension there, to 0.8. And there we are, we're fully constrained. Okay, so we can close that sketch, and now what we want to do is datum plane, turn that off. Okay, so we want to make a sketch down here about 2 mils down, I think it is. So we'll just go back to here. So datum plane. Okay, make dependent copy. It's this one, and then placement Z 17, 16, 15. There we go. Apply. Okay. We're going to draw on that. No. What was the height of that? I think it was about I don't think it was that low. I'm going to bring that up about 0.5. Placement 15.5. Yes, that's what it was at. Apply. Okay, and that seemed to accord with the screw as well. So we'll turn this cone off. We'll turn this sketch off. You can turn things off just by selecting it and pressing the space bar. So, okay, and we'll create a sketch on that plane, and we're essentially drawing, is that the XZ plane? We're essentially drawing, oh, what happened there? No, we don't want that. Okay, we've still got that, that's great. So let's get rid of that sketch. Let's get rid of that, yes. And let's see where we are now. Yes, that looks good. So datum plane, create a sketch. Okay, that's what we want. So it's the same again, just a smaller version of the crosshair. So we'll go No, I didn't want to do that. I wanted a constraint. Sorry, I mean, I wanted them to be... Okay, and then... Okay, right, and I want that one, these all to be equal. It's just the same again as last time. E for equal, and then these all equal, and then this, these two dots symmetric around the x-axis, and then this symmetric around that axis. Okay, and this is 0.6. Whoops. 1 point to that should be 0.6. Okay, that's great. And now we can do there to there as 1 millimeter. 1. Great, that's it. So now we just close that. We can turn off our datum plane. We can turn on second sketch. What we're going to do is sweep between these two here. So all we do to do that, or is it loft? I can't remember. Part, not path. Part. So is that? It's loft, I think. So we take sketch 2, sketch 3, create a solid. Okay, there we are. That's our part. We're going to subtract that from our head. So if we put the cone on now, all we do, select that one, select that, oh no, select the cone, select loft, and subtract. There we are. That's our end part there. So just to finish off, we just have to select that one, and do a fusion. And we can do a couple more things. We can put a fillet on there, 2 mil. Oh, that looks pretty rough, doesn't it? If anyone knows how to get that better, look what's happened there. It's because of the helix, I think. Let me try 1 mil. I maybe should have done that before I swept the helix. Let's see if I can sweep the helix again. So if I won't need to sweep the helix again if I can join these two. Let's see what we've got there. Yes, let's try chamfer now. 2 was about right. Yep, that's a lot better. And we can put 0.1 on there. 0.1. Okay, that looks like a real screw. It really does. So we just have to do this final fusion. Of course, without the fusion, the end here looks just fantastic. But it's when we do this fusion, maybe if I turn those initial sketches off, it somehow makes a difference. I don't know. You see the green there, the sketch just under the mouse, and the white there, the sketch buried inside the thread. So we press the spacebar on those sketches and turn them off. And let's just try a final fusion. Yes, the end's pretty ugly there. So if you know how to fix that, let me know. I don't know what to do about that. But other than that, it's very realistic looking wood screw. It does look very realistic. Okay.